Hello students, welcome to my channel Physics Galore. Being a first class, let me give the introduction on physics. Physics is systematic study of nature. Systematic study of nature. We know well, nature, which is nothing but universe. The universe is made up of matter. Universe is made up of matter. Now we are going to study what are the properties associated with the matter and what are the energies associated with the matter. So finally we are going to calculate what is the matter and what is the energy associated with the matter. That is simply we can define or give different definition as physics. So physics is simply study of matter and energy. So in our day-to-day life we have come across so many energy sources. So different types of energy sources. We call it as potential energy, kinetic energy, magnetic energy, electrical energy, sound energy, light energy, tidal energy, wind energy, geothermal energy, and etc. We can keep on add. Now let me explain one type of energy now. Potential energy, for example. Potential energy is, the proper definition is energy possessed by a body which is at rest. Energy possessed by a body which is at rest. The formula used to find potential energy of an object or a body, simply potential energy equal to m into g into h. M, g, h. Here m is mass of the body, h is height through which we are lifting the object, or g is gravity. So what is acceleration due to gravity? Acceleration due to gravity, I am taking it as 10 meter per second square. Actually 9.8. For our simplicity, I am taking it as just 10. Now, in my past experience, I understood that students are very much finding difficulty to solve the problems, because physics and problems are quite kith and kin like. You cannot avoid solving the problems in physics, because as far as you are applying the concepts in physics, you must solve the problems associated with it. So let me give you simple illustration to calculate what is potential energy. So formula we know what is potential energy, m, g, h. Now give some example. Now let mass be 10 kilogram. Let height through which a body is lifted is some 10 meters, and gravity we already know, which is constant, is 10 meter per second square. So multiply all these three. So 10 into 10 into 10. This is m, g, h. So what is potential energy finally? Just multiply these three. 1000. What is the unit of energy? Energy is measured in joule. Energy is measured in joule. Either you can write it as joule fully or simply the symbol J. Just to honor the scientist, joule. Okay, now we'll go for another type of energy, which is kinetic energy. Kinetic energy is defined as the energy possessed by a body which is in motion. So energy possessed by a body which is in motion. For example, we already discussed the potential energy. For potential energy, the example is check dam. We are storing water in a dam, which is potential energy. When you are releasing the check dam, what happens? Water flows out. Water flows out. While flowing, the water consisting of energy, which is kinetic energy. Now, potential energy becomes kinetic energy. Now, kinetic energy of an object. Now I am rolling one ball. I am rolling a ball on the ground, which is possessing kinetic energy. The kinetic energy possessed by a ball can be calculated with the help of a simple formula, half mv square. General formula for kinetic energy is half mv square. Here m is mass of the body, v is speed with which the body is moving, speed of the body. Now related to this, we will solve a simple problem. Now if m is given and v also given, you can simply calculate what is kinetic energy of the object. So So kinetic energy here, let M be some 5 kilogram. M is 5 kilogram. Let V is 10 meter per second. V, value of V, the speed with which body is moving is 10 meter per second. So what is the kinetic energy then? Kinetic energy, we know the formula, half mv square. What is m here? Half. M is 5 kg. V is 10 square. So half 5 into 10 square. What is 10 square? Is 100. Just to cancel it, 50 times. So 5 into 50, 250. Again, this is kinetic energy. This is nothing but energy only. So unit of energy is joule. So 250 joule is kinetic energy of a body of mass 5 kg and moving with a speed 10 meter per second. That's all. That is the calculation in physics. Now we are going to discuss one famous law which governs the energy, which is law of conservation of energy. Law of conservation of energy states energy can neither be created nor be destroyed, but one form of energy can be converted into another form. That you would have studied in your earlier classes, I believe. What is the law states? Energy can neither be created nor be destroyed, but one form of energy can be converted into another form. Let us give one example for it. Now, I am going to convert electrical energy into heat energy. So, you yourself can give some example. In day-to-day life, we are using at home, electrical energy is converted to heat energy. You are doing iron, you are ironing your dresses, right? So, in iron box, electrical energy is converted into heat energy. Similarly, heat energy can be converted into electrical energy. That's what happening in the thermal power station. We are generating electricity with the help of heat. We are burning the coal. From the burning of coal, we are getting heat. That total heat is converted into electrical energy. That's what happening in thermal power stations. Right? Now, to go for another example, electrical to mechanical energy. So, as soon as you switch on the motor runs. Running of motor is mechanical. Now, again, mechanical can be converted into electricity with this generator. Example is electric generator, what we are using in malls and theatres, etc. Right? So, conversion of this simple conversion of one energy into another energy is full study of physics. Clear? Physics means concepts. Concepts we are going to use in some kind of applications. While applying the physics concepts, you must solve some problems related to those concepts and applications. While solving problems, it is very, very important to know the multiples and submultiples. The scientific notation, that is prefixes for powers of 10. Very frequently we are going to utilize in solving problems in physics. In this case, what we are frequently using is 10 power 1. You already are aware of it, 10 power 1. That means 10. 10 events we call it as decathlon in sports. So 10 power 1 is nothing but 10, which is deca. 10 power 2 is hecta. 10 power 3 is kilo. Symbol is K. These four we are going to use very frequently. That's why I mentioned the symbol of those prefixes. 10 power 6 is mega. 10 power 9 is giga. 10 power 12 is tera. 10 power 15 is peta. 10 power 18 is exa. 10 power 21 is zeta. 10 power 24 is iota. You just forget all these four. We are not going to use, but we are going to use very frequently these four: kilo, mega, giga and tera as far as physics problems are concerned. Right? I will go for powers of -1. 10 power -1 is deci. 10 power -2 is centi. For example, the problem is given in centimeter. So immediately centi refers to the multiples 10 power -2. So 10 power -2 meter. So 10 power -2 meter is centimeter. Clear? Similarly, milli. 10 power -3 is milli. Symbol is small m. 10 power -6 is micro. Micro symbol is mu. This is mu. 10 power -9 is nano. 10 power -10 very frequently we are using in solving the problems related to light and its wavelength. 10 power minus 12 is pico, symbol is P. 10 power minus 15 is femto, Fermi. Among all these 10, 12 prefixes, we are going to concentrate on centi, milli, micro, nano, angstrom, pico and Fermi. Very frequently used in solving problems. Femto and Fermi very frequently we are using in studying atomic and nuclear physics. So nuclear distances, atomic spaces are measured in Fermi or femto. So in order to solve the problems in physics, you must be thorough with these frequently used prefixes for powers of 10. We simply call it as multiples and submultiples. With this small note, I will put an end to this introductory class. Our next class will be full and full from your syllabus, whether you are studying plus 1 or plus 2. Videos will be uploaded in my next session videos. Goodbye.